So welcome to this talk, good morning, and we're going to be talking about some ways which we can secure database credentials on the client side. And before we jump into it, I'm just going to quickly introduce myself. My name is Helen, and I live here in Auckland. I'm working at Aura Information Security, and we have offices in Auckland and Wellington and Melbourne as well. So my role there is a security consultant on the penetration testing team. So our job is to basically, have a look at customer systems and web applications and help them to secure it. And the display just disappeared. How did that happen? Oh, is it some connections? Let me just try that again. While he fixes that, I'll just keep introducing myself anyway. And before this current role, I was working as a software engineer at Microsoft in Vancouver. So that was really fun, and it really, because of that role as well, I'm really passionate about thinking through security in software, especially from a developer perspective, and how we can be writing code that's secure. And most importantly, I'm actually currently on maternity leave because I have a 3-month-old little boy at the moment. He's really cute, and really enjoying not having any work responsibilities, although there's the responsibilities of being a parent now. But also have to give him a shout out because this talk was pretty much written entirely while he was sleeping. So without him sleeping, I feel like, I wouldn't have been able to finish this talk. So thanks to him. And also, the next slide is actually just thanking our sponsors, for all of them sponsoring this event and making it all happen and bring us all together. Definitely an event I look forward to every year, so thanks to all the sponsors. All right. The slides are still going up, but I'll just describe what's on the slide. So imagine you're looking at a house with some mats, right? So this is the analogy that we're going with. Who has ever left your spare keys outside the house somewhere? So just so you have a way of getting back in. Right, either you have or you know someone who has done that before, because it's just so convenient and you don't want to be locked outside the house, right? But while that's really convenient and an efficient way of accessing your house, there's also a lot of security issues related to that, right? Because not just you, anyone who comes to your house, if they just looked around a little bit, maybe they'll be able to find it and also get access to your house. And actually that's something that's very similar to what we do in software applications a lot of the time as well, because we want to prioritize, we want to make things easier for us. We want to make sure that we are building software in a way that's efficient and fast. Oh, I think it's just the other tab. But in doing that, we actually sacrifice some security in that process as well. So, cool. All right, I think it's almost back up. If you click on the slideshow, top right, slideshow, presenter view. Oh, okay, that's fine too. All right, just do it without my notes. Cool. And we're past that. Here, I can do this one. Thank you for your help. Thanks, everyone. So that was the house I was talking about. And then there's a key. So in this talk, we're going to be covering, these are some of the main points we're going to be covering. So we'll start off with a little bit of a background on the issue that we're looking at. And then we're going to have a look at a case study, which is from a pen test that I did a couple of years ago. And then at the end, we're going to have a look at the solution, right? Which, spoiler alert, it's using S3 PreSign URLs. Not sure if you've heard of it before, but we'll have a look into how we can do that and implement it securely as well. So just to have an overview of software architecture, when you're building a web application, usually you have a user that communicates with the front end of the application, which displays all the information to you, right? And then the the front end will be communicating with the backend server, the application server, which contains all your application logic. That's where you write the majority of the code. And 99% of the time, if it's a web application that does anything important at all, you need to communicate with a database. But what we're seeing more and more these days is actually also the use of separate cloud storage, right? And the most prominent of these might be AWS S3 and also Azure Blob Storage. And these are essentially just key value stores. You just give them a key and you get an object back, right? And it's really good because you can store really large information on there. So I think S3, you can go up to 5 terabytes for a file. So really efficient and really good way of storing unstructured data. But there's an issue with this type of architecture, especially when file upload is involved. Especially, a lot of people use storage to store things that's quite big, so media files like movies and PDF files and all those kind of stuff. And imagine if a user wants to upload something to the application. Usually it will go through the backend, and then the backend will authenticate with the storage, give them the username credentials to prove that you can upload to this storage, and then the file will be uploaded. But the issue with that traditional architecture is that it uses a lot of bandwidth, especially for the application server on the backend. So yeah, so it can get really busy and uses a lot of storage, uses a lot of computing power on the server. So especially it's not great for some kind of application that deals with peak traffic, right? So something that gets really busy around Christmas time every year or a special occasion. That's because then everything would be, the server will just get overloaded with all the uploads, especially when you're involving large media files. So what we're seeing more and more is this type of architecture where we're bypassing the backend and uploading the storage directly from the front end. But while this has a lot of benefits, namely you probably pay less for your server because now it's not using as much traffic and as much going through it, and probably be a bit faster as well. But the front end of the web application is actually all visible to the user. So I'm not sure if you realize this, because I feel like I didn't know this for a pretty long time, being someone who uses the internet. But yeah, everything you see that's displayed in a browser, the HTML, CSS, JavaScript, they're all visible to the user, as well as all the requests and the response that the front end is communicating with the back end as well. Right. So a big part of what we do in penetration testing is to intercept the request and have a look at what's going on in there. So all of that is visible to the end user. So now we have the problem of we need to make sure, we both want to make sure that we're uploading from the front end, but also doing it in a secure way, because if we're uploading it from there, we're going to need to prove that we can upload to the storage somehow. And to do that, usually we'll need user credentials. Okay. So let's have a look at a case study of a company that didn't do this very well. This was an engagement with a New Zealand company a couple of years ago. I've completely anonymized it, so I think no one would be able to know what company this was. And in this case, the exposed credentials actually led to a complete database breach for this company, which was not really good, and they were very panicked. But they fixed it really quickly as well, within a week before Christmas. I felt a bit bad for the developers, but yeah, so let's have a look at this case study. So we have a upload file functionality on an arbitrary website, just a company name I made up. You see that everywhere, right? You can upload files very easily in a lot of web applications. And what happens when you click that upload is that the client sends this request, which is essentially, it's an HTTP post request, and it's saying, cool, I'm going to upload this file with some parameters and some names. And then the server sends back this response, and it's like, oh, cool, yeah, got it. So you can, here's some information for you to know. But there's a very interesting variable, right? So I was immediately drawn to this AWS config variable, and base 64 encoded string. And base 64 is just basically a way of encoding something into something else. And it's completely reversible as well. So let's try to decode that. And turns out it's actually a JSON string of something called access key ID and access key secret. You don't have to try using this. I just made up the letters. It's not going to work. I'll be surprised if you can actually execute with this. But yeah, so if you know anything about AWS, this is the parameter that they use for their credentials. So immediately I was like, oh, this looks really interesting. So I was actually curious, like, what are they doing with this AWS config? Like, why do they actually need this in the application? Why is the server sending it back? Right. And it turns out that this is the JavaScript code that they have, which I can see being in the front end. It's just taking out those parameters and then performing an upload functionality. Right? So it's uploading it directly to the S3 bucket through the JavaScript code. And to do that, the server opted to send the credentials to the client, and then they're using it to upload it. Right. Obviously not a great idea, because what actually happens is then I can use this and to just enter it in AWS CLI, and I can see all the folders that's stored on this bucket, and all the things that's grayed out are the company names and potentially identifying information stuff. But the most interesting one was down here, something DB backups, right? Which again sounds really interesting. And then when we go in there and we have a look, it's just a bunch of folders with dates on it. And inside one of them, it's got 3 files, something SQL, right? And once again, those were just company names that were grayed out. So these were and all the folders had the same 3 files. So they were doing a backup every day of the key database and then uploading it to S3, which is great practice, by the way. You should be backing up your database regularly. But in this case, what wasn't great is that I was able to access it, because I was just a normal user on this web application trying to upload a file. And then so I downloaded the files, the SQL files, and it actually had all the username and password hashes for all of the users from this company. And other than that as well, because they were really big database backups, it also had a bunch of other information about the company and the users, and stuff that's probably private, that they don't really want people outside their company to know. Yeah, so wasn't great that I was able to see all of this database backup. So yeah, so a quick recap of how this all happened, right? So the web application was just trying to send a file upload request, and the server sent back the credentials, but all of that was visible, and then the application is trying to, and then uses the credentials to upload it directly to S3. So then, yeah, actually, like I was saying before, anyone such as myself who had access to the functionality, essentially they also had access to all the database backups from the company. So going back to our analogy at the beginning, essentially what they did was they thought that maybe no one would be able to see these credentials because we're just uploading it and we're base 64 encoding it. Right? It looks so jabbled. No one's going to know what's actually there. But in reality, if anyone knew where to look, they can get access to these credentials quite easily, really. So just diverting a little bit. So this issue is actually related to one of the OWASP top 10 issues called, this one in particular would be related to cryptographic failures. So in the new update, it's changed its name from sensitive data exposure to cryptographic failure, because really every time you have a sensitive data exposure, it's just a result of having some sort of cryptographic failure. You're not encoding, you're not encrypting something safely, and that's what leads to the exposure of the sensitive data. And it's actually moved up from 3rd place from the previous one to 2nd place from last year. So it shows that a lot of companies and web applications are struggling with these kind of issues, and it's quite prevalent, and it definitely can have very devastating consequences as well. Right. So once again, yeah, so the hacker in there is able to intercept the credentials in there, and that's where the cryptographic failure is happening. So what should we do? Here we have a problem, right? Because we want to both upload directly from the front end, because that's efficient, that's great, everyone is happy, cut down on your server bills, but at the same time, the client shouldn't have access to the credentials, right? Because everything is visible to you, to the user, and you don't know what the user is going to do with them. So how do we get the client to upload without the credentials? It feels like kind of, yeah, just not going to really be able to happen. Right. So AWS solution for this is called PreSign URLs. And essentially what they are is they're these URLs, and they grant temporary restricted access to objects in the AWS S3 buckets, and it's only valid for a predefined period of time. So it's going to expire eventually. So when you want to create this URL, you need to get an AWS user, specify what action you want to, or specify the object first, and then the action you want to allow people to perform, and then you use your secret key to sign the URL. So then you'll be able to essentially say that I have sanctioned this action. I allow whoever has this URL to perform the actions. Right? So then anyone who has access to it can either get the object or update the object with put in the URL. So it's if performing it on behalf of the user who signed this request. So then that way you don't need to have any credentials floating around in the front-end side. So our new approach for upload would be, once again, a two-step process. Firstly, we'll obtain a PreSign URL from the backend, and then we'll use the URL to upload the object from the front end. So back to this diagram again, instead of having the server send the credentials to the client, we're just going to send the PreSign URL, and the application then will use the URL to upload to the S3 bucket. And then when the action is being performed, S3 is going to check the signature in the URL and make sure that it's valid, it still hasn't expired, and the user who signed it has the permission to perform the action to the object. Right. So just have a quick look at what this looks like when you're trying to create a URL in Python. You can do this in pretty much any language that has a AWS SDK attached to it. So in Python, this is what it might look like. You create a client, you specify the access key and the secret in there, and this is happening on the back end, right? So the user is not going to be able to see this code. And then, yeah, the PreSign URL, when you're generating it, you just need to specify the action, the put object, the bucket, and the key, which defines the object that you want to either create or update or just retrieve. And then finally, you need to specify how long it will last before it expires. So in here, it's 1,000 seconds, but you can also just leave it blank to use the default. So yeah, and this is what it looks like, right? So it's just accessing like the file. You have the file name, the bucket name, and then the signature here, the long string, is what the S3 is going to check against to make sure that it's all valid, and you can use it to perform the action you want. So this sounds great, right? Like it's such a great way of uploading or retrieving things without ever touching your URLs. Ever touching your credentials. But like with everything, you also need to make sure that they are also implemented securely. So here's a couple of ways, just some of the key points to think through if you're thinking about using these URLs. So firstly, it's really important to make sure you're limiting your expiry time. So like I mentioned before, once this URL is generated, anyone can use it, and it will be valid for an unlimited amount of time before it expires. So if someone were to get a hold of this URL, they can potentially use it to upload several times. Like if it's valid if it expires in like a year's time, that's 1 whole year which you can use it to read this file or to update this file. And it might not be something that you want depending on your use case. And the default expiration time is 15 minutes, which can be quite long if you're only really using it to just perform one action and then you're done with it, right? So depending on your use case and how fast the server response is, you might want to make sure you keep that as short as possible. And yeah, just making sure that the URL is only valid for the minimum amount of time that helps you to achieve your task. The second thing is making sure that the user who signs the URL has the least amount of privilege, right? Because when you're creating these URLs, the URL essentially has the same permission as the user who have signed it. So you want to make sure you create a separate role for the user who's signing these URLs. And you want to also make sure that they have the least amount of privilege so that, so for example, this user shouldn't have control over your entire AWS system bucket or whatever, because they don't really need that if you're just really using it to create a URL. And making sure you only grant the necessary permissions for it. So this might only really be just to read the object, a specific object in this bucket, or update objects in this bucket. And it's actually really good practice for instance response, because what happens is if you suddenly realize, oh, we have a bunch of these URLs that's now exposed, you can't really stop people from using it before the expiry time because it's going to be valid up until the time it expires. But what you can do is you take the user who signed these URLs and you take away the permissions from them. So these URLs will then become invalid immediately, right? And this is really good if you have a separate user for that, so that you don't really get it all tangled up with all the other things you need this user for. So yeah, separate user with the minimum amount of privilege. And this is what it might look like for the policy when you're creating the separate user and what they're and specifying what actions that they can perform in the specific bucket. Third thing is you might want to consider, if you're doing file uploads, consider to make sure you can control the file content, right? Because by default, if you have a PreSign URL that you can use to update, if you don't specify what file is being updated, people can actually overwrite the object and they can use this URL to update a malware onto your S3 bucket, and you probably wouldn't know about it. So you want to make sure that the file that is eventually being uploaded with the URL is the file that was intended by the original person who wants to upload the file. So what you can do is you take a hash, MD5 hash of the object, of the file you want to upload, and you add it as a header. And then you sign that all together with the PreSign URL. So when that is part of that, so when the user is trying to use the URL to update the file hash has to match. Right? So if it doesn't match, then it's not going to be valid. So this is a great way of making sure that it's being used as intended. And finally, we want to make sure you're enabling logging on your S3 instances. And this really, it's a generic advice because it doesn't really, it still applies if you're not using these URLs. But it's particularly helpful because this way you can actually see if these URLs are being misused on the S3 bucket, or if people are using it excessively or not being intended. So this is actually, logging is somehow not enabled by default, I believe. So definitely make sure you go in and check that. So these couple of things are definitely not an exhaustive list of how you can secure them, but it's really important whenever you're implementing something to think through these things and also just have a bigger picture of how you can make sure everything is secure. And as a penetration tester as well, these are good things to be looking for if you ever come across these URLs in the wild, which I think, might be becoming more and more prevalent, hopefully, it's a better way of uploading or retrieving files compared to the using plain text credentials. So yeah, and the takeaway message, essentially just remember that everything in the client side is actually all visible. So everything you do there, just think twice about what you're saving, what you're sending to the client, and is it really necessary, and what's the worst thing that can happen? And especially every time when you're working with credentials, make sure you're thinking really hard about where it's stored, where it's being transmitted, and how someone could potentially have access to it. And thank you. So hopefully that was helpful. It's my yeah, feel free to contact me, and I'm not super active on Twitter, but I'll see messages if you send me a message, and yeah. Cool.
Awesome. Thank you very much, Helen.